All right, so let's ask a question. Who all here knows about threat modeling? Raise your hands. Okay, who all here enjoys doing threat modeling? There's only a few people. Fewer people, okay, great. I love doing threat modeling. And actually, Nick was talking about Adam Shostak beforehand. And I worked underneath that guy for quite a while, back when I was working at Microsoft. So he taught me a lot. He also taught me that this thing right here can be improved, threat modeling. And that's what I'm going to tell you about. So a little disclaimer right here. This is Creative Commons, so once I pass it off, you guys can copy it and whatever like that. Just don't make any money on it. Okay, who am I? Has anyone read any of my stuff? No, you haven't, of course. The main thing here is that I've started a company called Tutomantic, and I'm trying to solve the problem of threat modeling manually by automating it. So if you see that little guy right there and everything, you can go find out more about it. Or if you want to talk to me later, awesome. Great stuff. Now I'm going to get into this. There are going to be 4 bullet points I'm going to talk to you guys about. What should threat modeling do? That's the ideal. What it actually does, that's the less than ideal. An overview of secure agile architecture. Does anyone, show of hands, understand what agile architecture is? How about non-agile architecture? Architecture? There we go. Okay, I got a few people. I just keep on going down and down and down until I get enough people on it. And then finally, I'm going to introduce rapid threat model prototyping. You all ready? Good. All right. So what should threat modeling do? Show of hands, should threat modeling provide you with the full solution of security at the beginning? Should it provide you with a little bit of solution about security in the beginning? Should it work upon different plans, upon different architectures, the same methodology? Is that what it should do? Oh, wow. Responsive audience. I love it. Yes. Great. Just stare at me and go, what the hell is this guy talking about? Well, threat modeling should solve this, first of all. Core security concepts of secure by design, secure by default, and secure in deployment. So it should answer this. It should answer like what in your design needs to be put in defense in depth. Do you understand what defense in depth is, right? Every component defends itself. And especially in the cloud, this becomes more important. The secure by default aspect has 2 parts to it. It has the principle of identity and the principle of least privilege. So principle of identity is, who am I? Am I allowed in the system as a person or as a thing contacting the system? Or am I anonymous? And the principle of least privilege is, once I get into the system, what can I do? If I can do everything in the system, well, that's not least privilege, is it? Threat modeling should answer that. And then finally, the last 2 parts in the principle of deployment is, what are the endpoints that the system communicates across? And what are the protocols? Protocols is very important because most of the issues you'll find are mistakes in protocol, misconfigurations, which allow people to come in and break that least privilege bit, execute on least privilege, and become what they shouldn't be inside the system. Threat modeling should also describe everything in this. Show of hands if anyone's seen what this is beforehand. It's an old ISO. It's ISO 15408 from 2005. Okay, great. No one's seen it. That's fantastic. It shows all the different interrelations right there. The one thing it doesn't show is threats mapped to countermeasures. That's why they didn't do much threat modeling back in 2005, I guess. Threat modeling should point out flaws versus bugs. Okay, a flaw. A flaw is something that is inherent in the system. It doesn't matter how good you do it, you're still going to have a flaw. What is a problem with flaws? Flaws, especially in designing software systems, means that I designed this system and then later on the system has a number of dependencies based upon that design. How am I going to fix it? If I go back and I find there's an issue right there, I'm going to break a lot of things, aren't I? However, if I didn't implement it properly, then I'm not going to break that many things because the underlying design is actually more secure. Threat modeling should also take care of this. Who all seen this? Anyone? No? Bueller? 1 or 2 people. Don't worry, guys. I'm going to share out the slides to you afterwards. You don't need to take photographs. But you can if you want. Just leave me partly in or partly out. Threat modeling should answer modeling the system, understanding the zones of trust, should model the threats themselves, should answer what the mitigations are and how you're going to respond to them, and then finally some way of validating that these mitigations are correct, right? It should do that. But what does it do? Well, first of all, how many people have been in meetings where everyone starts arguing, you get a bunch of people together in a meeting, you say, we're going to do a threat model, and you spend all day arguing with each other about what the threats are because you don't have any kind of organization. And a lot of people get frustrated and like, have you forgotten about this? Have you done this? Have you done this? And since there's no organization, as Nick said beforehand, let's have a meeting. And you have a bunch of meetings, and the meetings don't necessarily work out, and they have more meetings on top of the meetings, and you never get a full threat model out. And by the time you get the threat model out, well, you get something like this. Anyone seen these data flow diagrams? Because you're drawing data flow diagrams out, you're like, well, wait a minute. Well, maybe it's there. Maybe there are issues right here. We don't know. And then you work a little bit harder, and then you get something like this, which is even more of a mess. Does that thing relate to anything that I have in a design? I don't think so. I don't think there's any architecture that describes that the way it is. You end up maintaining that. So now you have to maintain not only that, but you have to maintain everything else. And these data flow diagrams get out of date pretty quickly, and no one wants to maintain them. You're going off, you're doing other work. So finally, pressure on your time, you got a lot of other things to do, and you get this. Sprint 1, Sprint 2, and you don't have any threat model anymore, or the threat model's gone this way, and your entire architecture's gone this way because no one's maintaining the threat model. That's the bad things. But I'm going to show you a solution. Solution: secure, agile architecture principles. Yeah, all right. Hey, all right. Come on, guys. Yeah, there we go. All right, yeah. I know it's fake, but still contrived. All right, secure agile architecture principles are founded on two major concepts. One concept is the intentional architecture concept. It's what you normally find in your orgs. Those are the guys who sit in the white ivory towers and tell you what to do and what not to do. Basically, it marries up the strategy, which is a business side of things, with the enterprise architecture, which takes care of things such as what are the functions within the teams, what kind of technology we're using, what are the principles that we're following upon. And they marry up with the business part. What is a vision? What is a mission of the business? Because the problem is usually we'll design a bunch of tech stuff out there with no idea about the business. The business people will say, we want this, and we'll give them that. Okay, so this part right here, this enables cross-team collaboration and enables us to pull the strategy down into the weeds. The second part is what they call emergent design. And emergent design has a whole bunch of different organic things to it. The most important thing I've circled up there, it's called model storming. And model storming is essentially you get the team together, you are the security person, but you get a team together because the team knows the product. The team will work on the product and you help them out. You kind of like think of yourself as a sheepdog, and the team's kind of running one direction, you kind of nip at their heels and you nip in one, and you get the sheep to go in one direction. Sorry developers, and then they come up with an idea and they say that's a good idea. And they end up making the model. They end up making the threat model with your assistance, but you're not actually designing it for them. Because ultimately it's the team who wants to own the result of the threat model, and they want to be proud of it too. They want to provide a better product. So we get to the point of talking about rapid prototyping, because this is where we get the whole threat model rapid prototyping bit. 4 points of this. You find out what your basic requirements are. Well, we're going to do that, right? Because generally when you get a team started, you write stories. The stories are going to provide your basic requirements for that sprint. Then you do a conceptual design. Well, generally you're going to get that from the architects. They're going to say, here's the design, here's what we want it to be, rah, like that. And you're going to take that design and you're going to annotate that design. You're not going to make your own. Then you're going to test the prototype, provide feedback, revise, rinse, wash, like that, and now you've got prototyping. So let's marry that up. We want to get 3 things out of this. A consistent framework. That's what my prototyping will do, my rapid threat model prototyping. Thank you. We want to get a repeatable process. I want to keep on doing this and have it be able to, ultimately I can automate this, because automation is good. And finally, I want to have measurable data coming out of this. I want to find out if I'm doing well or not. How many threat models have you guys done? No, that's the wrong way. Have you done any threat models where it's easily measurable? Show of hands. Crickets. I thought so. Because normally we can't measure threat models, can we? The output. We can measure it kind of, but we don't have any kind of way of actually taking numbers out of this and distilling something out and saying, look, we can churn this back in and we can show some difference. We don't have that until now, he says. So it's based upon the Pareto Principle, 80-20 rule. 20% of the effort will get you 80% of the way. So you want to provide just enough information. How are we going to do this? Now, ta-da, the introduction to rapid threat model prototyping. We're going to base it, this further on discussion, we're going to base it upon the DevOps steps. Take that number 8, turn it sideways. I'm going to walk through each one of these steps right here, and how do I apply the rapid threat model prototyping to it. Now, hold on to your hats, folks. If you don't have any hats, well then hold on to your seats, because I'm going to go through a bunch of steps, and they're going to be fast, and I don't expect you guys to walk away knowing this fully, but I expect you guys to understand how the logic goes. Step number 1. So, communication across groups, we want to use a common security framework. Can someone yell out a common security framework that they use at work?
NIST.
NIST. Okay, that's a good one. Anyone else?
CISP.
CISP. CISP?
CIS.
Oh, CIS. Okay, good. All right, not you, but who else? You got 2 points. Anyone else? OWASP, any chance? Like OWASP Top 10? It's not a framework, but it's something that people can use, right?
One of the ISOs that begins with 2.
Any of the ISOs, you get the idea, right? We want to use a simple framework. I'm going to use Stride, and I have been using Stride. I've got one problem with Stride, though, and that's the number 3 element right there is repudiation. How am I going to explain non-repudiation to people? You know, repudiation is the opposite of non-repudiation. The reason I'm going to use Stride is I'm going to use this. It's easy for me to teach to people who are not security people. Yes?
On that tangent, do you actually use Stride like anymore? Stride came out of MS, right?
Yes, it did, and I do.
Does anybody use like recently?
Oh, people do, yeah.
Seriously?
Yes, seriously.
Christ.
You know why? It's easy to teach. And if you do this, you can map Stride to CWE. And if I can map Stride to CWE, I can map it to OWASP. Yes, you can. But that's a gateway. That's a gateway drug. I'd rather not teach CWE to people when I can teach Stride to them. All right, we can talk this offline too. I do like your questions though. And I like your verb, yes. All right, I'm going to replace repudiation with authentication and integrity. Because I'm going to say that lack of authentication and lack of integrity, I can then repudiate that I was there. It means if I can spoof and if I can tamper with the data, I can get rid of the way that I'm repudiating. So that's the main replacement right there with Stride. It makes it easier for me then to explain to people. Because tampering, information disclosure, and denial of service are also CIA components. Who all here is familiar with CIA? Confidentiality, integrity, and availability, right? So I've got another one nested in here. Now I can explain 2 different frameworks for the price of 1. And during my day-long course, I actually have people map this to the CWE, and then the lights start going off. All right, next thing. We want to build on a current process diagram or context diagram. Why? I don't want to go and rebuild things. It's a pain for me to go and say, okay, I'm going to do a proper threat model, and then all of a sudden I have to build my own data flow diagram, which doesn't look like what the underlying context diagram is. Context diagram changes, and guess what? I got to go back and change my diagram? No, it doesn't fly. So I'm going to use what the architects give me. Something like this. This is actually this is a diagram that I put together, but it's actually a diagram that really exists. So we have, 2 ways of getting in. We either have an API or a website coming in, and then we have a bunch of components flying in there. We have 3 databases that are flying around there. Okay, great. You've got the internal setup right there, and you got a cloud component. The most important thing in any diagram to find is where you can elevate privilege. And you want to do that first, and you want to do that foremost. And the reason is everything else, okay, identify recon, initial attack of your attack kill chain, fine. But the command and control bit, elevating privilege is where they cause the damage. Then it can move laterally. So we want to create a way, that rapid threat model prototyping, where I can find that quickly. And I want to find it right away. So the first part of doing a rapid threat model prototyping is we add zones of trust we're talking about, where you find higher trust and lower trust. Now, how I define that is what is the criticality of the data going in? What is the criticality of the system? So if the system has a higher criticality, if I can break that system, then that's probably going to have a higher zone of trust. During Sprint Zero, we want to do this. So get the team together, get the security subject matter expert together, and we sit down and we say, let's hash this out. Let's find out zones. A bit of guidance here. So defense in depth, we're going to build that into the diagram. And any inbound communication that's outside of the diagram or outside of your system is considered to be external. I don't care if it's inside the company. We're building a defense in depth here. Finally, those zones should be valued 0 to 9. We're going to put a numerical rank on them so later on I can measure this stuff. Point number 1. Anything that's outside of the system, anything that's outside of this particular system will be defined as 0. So your person over there and your third party over there are going to be 0. They're going to be outside of the system. Point number 2. We now want to take and we want to find what's the highest value inside the system, where data hits the disk. Look at the 3 points right here. You have a results data, you have blob storage, and the analysis rules. I've placed down 9 for the results data because that's where all the calculations are done, finished. 8, blob storage. That might be kind of interesting. And then 7, the analysis rules. I'm going to put that in number 7. So I'm just arbitrarily putting those numbers out there. We can change them afterwards. They're going to be the highest numbers in the diagram. Everything else is going to fall in between. Then I'm going to take everything that's got low trust to it, that's intentionally low trust, and on the boundary, and I'm going to give that a 1. So we know that the website and the API gateway are designed to communicate to the outside world. They're both going to have a designation of 1. That's just guidance, though, because you could conceivably have an API gateway that might have a 3 or 4, depending upon the information that gets flowing into it. In this particular case, that's not the case. Now I fill out everything in between. So I put in downloader component, has a 6, upload component of 2. These are sometimes arbitrary, but you can mix and match them until it feels like it works. What you want to do is you end up getting a zone of trust on every one of the elements in your model. Now I can take and I can pull that information out, and it's no longer just, shall we say, a non-contextual like information or anything like that. I can actually pull that in, and I can actually run with that. All right, apply the zone rules. So this is where I use the stride mnemonic. And with the stride mnemonic, I can go through and 6 different rules. The first rule we have right here is elevation of privilege. So elevation of privilege states, I've now got the zones laid out, the numbers, that anything from a lower zone to a higher zone, I'm going to say potentially I can elevate privilege on that. So I'm going to apply those on every one of the elements, the target elements that exist. In this case right here, it's on almost everything you see. I'm not saying this actually happens, I'm saying it's a hypothetical. What we're doing is we're playing a game here. We're going to find out by iterating through all these right here, what actually has an elevation of privilege after we've finished with our controls and our mitigations. But right now, I'm saying hypothetically, there's an elevation of privilege on every one of these targets. Next, spoofing threats. It's on a target element again. It's from anywhere where the zones are 0 or less to greater than 0. So you'll find it usually on the boundary. In this case right here, on the website and on the API gateway. That means that I want to have, those are the highest probability where I want to have identity found coming into the system. Next, I told you I was going to go through this fast. Tampering. Now tampering is going to happen on the flows because tampering is part of the CIA complex. So with tampering, it's going to happen from a low flow to a high flow or from a low point to a high point. For example, from the user over there to the website, potentially you could have a tampering on that flow right there. Makes sense, right? On any of these different flows right here, you have, for example, the analysis, the cloud over here, which is representing a queue going to the analysis. Potentially you could have tampering back there too. Might be difficult, but I'm saying it's a hypothetical. You want to watch out for that. Repudiation threats. On the target element, where you have potential of spoofing and potential of tampering, you might have a repudiation threat. So you're going to have it on the website potentially, you're going to have it on the API gateway, and then all the way down to the downloader component and the uploader component, potentially you might have that. You need to watch out for that. So you need to do something to mitigate that. Information disclosure threats happen from higher zones to lower zones. The idea being that you have information that's in a more secure zone, and if you're sending it to an area that's less secure zone, potentially you're leaking information. So in this case right here, you have 1 going from the queue down to data process is an information disclosure threat potentially. You're releasing out information. And then finally, denial of service threats. Denial of service threats goes on the flow or the target element, and it'll happen where it goes from less than 1 to greater than 1. So in the case right here, we're finding it that it's going to be at the API gateway and the website point right there, which is where we'd expect it to be. You might have denial of service threats happening deeper inside. However, the probability is they're going to be coming into the system where you have less control over the data. So I've gone over through all of those right there. You can actually then take and you can actually put a very quick threat model of the threats within half an hour. And I've been doing this for a number of years with a number of different groups. We run through the 6 rules. Then the next step comes. You've got the threats all set up right here. You can then take this and you can output it to a risk register such as Jira or anything like that, and you can track it, right? In addition, you take the mitigations. Now, this is where it gets interesting. As I talked to the gentleman right here, I can take and I can map Stride to CWE to CAPEC, because Stride and CAPEC map together, and it's a very powerful thing indeed, and eventually to attack. They all map together quite well. In addition, I can offshoot and I can map it to OWASP Top 10. Now I have a gateway into all those different more complex frameworks from a simple Stride. So now I can take, and since they've done all the work for me on finding the mitigations, I can then take my Stride elements inside of my diagram, and I can say, well, what mitigations actually apply to this? And I don't have to write up anything, do any research. It's all done for me by that mapping right there. Take those outputs, put them to the sprint backlog, and away you go. Now you can t-shirt size on calculated risk. You can move along from there. Now we come to the final part. You say you can now take that information and you can make it part of the pull request, so you can actually stop merges from happening if you see that people haven't put that mitigation in place and they haven't documented it as part of a ticket. You can stop it at the pull request. It never gets into the flow at all. It gets stopped and the person has to fix it within their own ID, within their own environment. And finally with reporting, I can take that information now. Because what have I done? I've numerically ranked all these different zones and I've placed it down to the very simplest bare bones, Stride. I can now take and I can pull that information out and I can start making, I can make reports on it, and I can send those reports out or I can send them out as JSON. And they can get consumed by other downstream components, such as risk tools, dashboards if we create them, such as Kibana, Logstack if you want, Splunk, et cetera, et cetera. We're using ArcSight right now, and we're pulling this into ArcSight. So, having said all that, having rushed through that, finally in Monitor, we can track these issues in whatever you choose, the flavor that you want, and everything like that. And that's it.